Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Camera Tuesday, we're going to talk about IMAX versus digital because IMAX is such a big deal and more movies are claiming IMAX. So let's understand it. So what exactly is this IMAX? Well, it's a proprietary ecosystem. You have to understand the ecosystem is a stamp, basically the stamp that you see, and it has to be there in throughout the supply chain, meaning how you are capturing the footage, how you are processing the raw footage, how you are making the final print that will go into a theater. All that has to be observed and managed and balanced by IMAX. Now if you do that, if you pay the money for that privilege, you end up with super quality movie, meaning if you are lucky enough, which very few of us are, who has the privilege of seeing IMAX in 70 mm, like actual film that is 70 mm big, the quality is unsurpassed, flat out on a different level. Like there is comparison here. And if the whole supply chain was done properly, as in like from the capturing to processing to final delivery, if all that data was done properly, it would be on a whole different level. Flat out, nothing on this planet can even come close to it. At least that's what IMAX tells you, everyone. So what is this film, like this IMAX? What is that? Well, it is what we call 15 perforations at 70 mm. Now you have to understand 70 mm structure, that 70 mm film is a common thing. It has been used in many cinemas. Even back in the days, that was like super resolution of that day. It's a common thing, but be mindful. That was done vertically. Basically, reel was going like this. Now benefit, it's a normal structure. That's how everything was. You just made the camera reels or specifically the projector reels a bit bigger. But here's what people figured out is that it barely had like 5 slots, 5 perforations. So what IMAX people figured out, what if we rotated the whole reel, basically rotate the frame in it, and voila, now you have far more surface area in order to capture it. That's why that 15 perforation is a must. You can't just say 70 mm. You will end up getting 70 mm of normal perforation, which is 5 mm. 5 perforations. You need 15 perforations at 70 mm. That is the IMAX standard, the horizontal reel, and that's why the projector is like this. It literally has to have that. This is how the movie is actually shipped to IMAX projector. So majority of the time you are seeing IMAX, you are seeing what we call LIMAX. Basically IMAX is flat out like, because they realize this sort of equipment, while it does give amazing result, it's idiotically expensive, very difficult to manage. So created a cheaper 2K digital variant of that, and that's everywhere. Most of the time that's what you're seeing. Now, enough people have realized that dude, it's just BS stuff, that IMAX actually try to upgrade their system to laser system and actual true 4K projection. That is a bit better, but nothing matches this 70mm, like actually having that 70mm thing. So let's understand the surface area. Why does that 70mm matters? Let's take a normal full frame mirrorless camera. So what kind of surface area we are talking about? Like how much area there is for the sensor to capture? That is 864 millimeter square. Good boy, like that's some significant surface area. So compared to this puppy has 3395, almost 3400 millimeter square. That's almost 4x larger, meaning you can literally put full 4 frames. Like literally take 35 mm film stock, if you have cut 4 of them, put them together. That's how big this puppy is. Now only few theaters have that. So to actually experience that, like when people talk about like IMAX master of that movie was so amazing, like the IMAX, the planet Earth was so amazing, you have to be there where you have that true 70mm. Yeah, at that point it would be orgasmic, but only few places are there. Now this whole setup, that figuring out the idea of like using this, consequence, it's too expensive. How expensive? Nobody can afford it, not even Christopher Nolan, flat out. And I hate this individual for that reason, because it's like, okay, you shot on IMAX, I get it. Why the heck you keep changing the format? It's like, it was the first time I'm noticing. Again, it may have been done in past, but that's how I knew it. And after this, I have noticed every other picture is doing that. It's like IMAX, crop max, IMAX, crop max. It's like, dude, scale one of them up. Scale the lower one up. It will look more than good enough, okay? Just, I really hate that when they are changing the aspect ratio. It's like, they're telling me, it's like, pay attention. It's like, no, all it is doing is distracting. So I really hate that part. And cameras are huge. Basically, these cameras are huge and they're very limited, because again, they also have a vacuum pump. Now, like, why the heck it has a vacuum pump? Somebody figured out if you directly just have a camera and try to have a roll of film that big, like this huge, going through it, it will shutter like this. So what do? You have a table behind it that has vacuum. So you shuck it in, and now you have a flat surface where you can project the image properly. Now you have truly good quality image. That was another minor development of this company. And consequence, this camera makes noise like there is no tomorrow. It's like, it's loud AF. It's not like, oh, camera. It's like, I am camera. Da, 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 da. That's how loud these things are. So this is what we are talking about whenever we are talking about IMAX camera. So what about the resolution? That's the first thing you will think about. So maybe IMAX have like ludicrously high resolution. Well, first thing you have to come down to the scientific level. Scientific level, you cannot say megapixel and or Ks. You cannot say 8K, 16K, 35K. No, no, just no. If anybody is talking about resolution seriously and they are using this sort of terms, nope, just no, flat out no, because that's not the proper tool for measuring resolution. Because be mindful, most of you should be old enough, and majority of you should have experienced that back in the days you had mobile phones that had cameras like as high as like 32 megapixel. Was it as good as today's 12 megapixel? No. Why? Megapixel was higher. That's the whole thing. Just because like Blackmagic can release a 12K camera, you will rarely see that used. Why? Does not mean it actually has the resolution. So how do we measure actual real world resolution meaning? So we use MTF. You must have heard this sort of term used when we are talking about lenses, and that's why you will always hear professional say, do not invest in a camera body, invest in a lens. Because again, if you have an amazing sensor, the latest and greatest sensor, and you have garbage lens be in front of it, it's useless. So what is MTF? Modulation transfer function. Meaning, we generally standardize this. So we have strips like this. So a strip is like white and black, and as hard edge as possible, and white and black, and they keep shrinking and they keep trying to make it as close to each other as possible. So in the starting, the gap would be, let's say, 2 millimeter, then in the middle it will be 1 millimeter gap, then it will be like 0.1 millimeter, then it will be like 0.10 millimeter. So like they will try to keep shrinking it. So that creates a mathematical wave function, basically how the digital data should look, or even in negative you can scan it, how the data should look. So it should have a square wave. It will keep shrinking in the amplitude. So you capture the image, then you process it. Now software is looking for this, and it will get something like this where it's shrinking. So you will call a point where it's like, dude, it's no longer black and white, it's just gray. That means lens is not able to resolve it. So that's how you know the limitation of the lens. So flat out, this is a law of physics. It cannot be breached, it cannot be bypassed. There is nothing you can do. If your lens is not resolving this, you cannot put a magical sensor behind it. You may put an AI there which is like trying to paint that information, it will still not work. So that's why, like, whenever you are talking about lenses that are used in observatory, spy satellites, why the heck those lenses are idiotically expensive? Because they try to use this, like this degradation of imaging performance. They try to make it as absolute as possible, as close to 100% as possible. Again, it's impossible, but they are very close to what can be physically achieved. What about your camera lenses? Yeah, lol, that would be like tweet. It's super bad. So reality is, unless you are dealing with some sort of equipment that is this grass, you do not can talk about resolution in terms of basically very high resolution. These are actually high resolution. Everything else is not high resolution because, well, their MTF is not good. So digital, like how do you compare like this function from digital sensors? Well, here's the deal. Negatives, we had enough experience, hundreds of years of experience. So we started like very tiny, like super 8 millimeter, 16 millimeter, super 16 millimeter, 28 millimeter, 22 millimeter, all of these things were done. So what we have realized very early on is that negative is inherently noisy, inherently. So that's why 8 millimeter, even if you put an amazing lens on top of it, it will not look good. Flat out, no matter what you do. That's why negatives keep starting to get bigger. That was the only way you can make a video that actually looked good. Even 8 millimeter, like people have this illusion where it's like negative can be scanned up to largest. No, it won't. It inherently will have so much noise that it will be useless. The mean transfer function will not be useful there. And that's why like 70 millimeter, you see this strip, that if you have normal projection like a vertical system, it will be only 5 perforation. You make it horizontal, now you have 15 perforation in one frame. So you have lot of surface area. This is largest surface area, and negative follows this very simple rule: larger equals better. So this will be fundamentally much better than 35 millimeter. That will be fundamentally much better than basically 16 millimeter. That will be fundamentally better than 8 millimeter. And you cannot have that brain damaged idea that people have, that like you can just scan it, like all you will get is green, nothing more than that. Like at some point you'll reach a point where it was, dude, it's just green. You are scanning grain. You can send it into electron microscope. You won't find color, you won't find detail, you'll just find grain structure. That's why making it bigger was the easiest way to get sharpness. Digital have crossed this threshold long ago, meaning if you take a 8 millimeter film camera, the best, the latest and greatest, take the latest and greatest lens in front of it, put a digital sensor will bitch slap this. That's why, like, flat out, any Tom, Dick and Harry is saying IMAX has a resolution? No. Flat out no. Like, flat out no. All space agencies used to use negative in their spy satellite missions, in their observatories. Why the heck they switched? Because when you need absolute data, I mean, I need data, not emotions, not feeling, data, flat out negative sucks. It does not matter even if it's as huge as IMAX. Meaning, what's the difference? Basically, you can achieve medium format like this sort of big puppies sensor sharpness if you have like the best lens on a sharp full frame camera. Right now, I'm not even talking about like 10 years from now. No. Today, you can have full frame cameras that are idiotically sharp. Put a really sharp lens on top of it, done. Like you can directly pitch slap medium format in negative sense, because modulation transfer function is inherently much better in digital. Inherently, that's why all the sensors are negative. Even though back in the days we literally used to put negative plate there. People figured it out. It's like, dude, I need data. I don't need hululu. I need data. Sensor, that's the best way of getting that data. So resolution wise, if anybody talks about like IMAX is this K and that can, no. And I'll explain that even further. Fundamentally speaking, digital is much better. You can have a digital cinema camera today that will bit slap IMAX in terms of sharpness. Like if you want like how small of a text I can read, how small of a detail I can read, IMAX will be bit slapped by majority of digital cameras, especially the large sensor ones. Then we come to dynamic range. Now, dynamic range is something you have to understand this way. It's like what is the brightest and darkest in a single frame. Meaning, if you take a photo and if sky gets blown out, you will say, okay, this is clips on the lighter side. If you take the same photo and like it, all the black dress loses all the texture, it clips on the dark side. A good, basically dynamic range will capture all of it as much as possible. Now here's the deal. There is a contention about people. It's like what is the dynamic range of human eye? Now some say it's 24 stops of dynamic range. Here's the deal, it's not. Now how the heck I know? Well, here's the deal. Your eye is not a cap camera. Basically, it's not like, okay, kuching, and then that file goes to your brain and your brain is studying it. That's not how it works. What it does is like my eyes focus on tube light, my sensitivity goes down, tube light is fully captured. Then I move my eyes, that's a corner area, that's very dimly lit. Now my brain increases the sensitivity, now I'm doing that. Now that creates a mental image. That mental image has like dynamic range of 24 megapixels. Why? Because our eyes are moving, like it's scanning everything. It's a more of a scanner. So, and that's why when we are projecting on a large screen, we need to have that dynamic range. So our eyes can naturally wander into the quote unquote scene and feel like, oh, real world kind of thing. That's why we want that. It feels real because, in real world, you can be like walking and there's like, that's a spot. The moment you look at it, your eye adjusts for it, you have that data. You look at a bright spot, your eye adjusts for it, you have that data. So we want dynamic range. It's not fair to the camera, neither digital nor negative can capture that much, but it is what it is. So low dynamic range simply means clipped highlight or lost shadow. What does clipping inherently means? In digital scenes, digital file or even in projection simply means there is no data. Meaning if you scan that spot under any sort of scanning equipment, you will not find any data. All it will have is just basically in sort of DSLRs, mirrorless, you will see this flashing light. Simply means instead of data there, all it is says white. There is no data there. Like you can literally take basically it would be equivalent to writing white text on a white paper. Your eyes can see it because your eye will keep scanning it. But if you overexpose that, camera will not be able to see it. So whenever you see this sort of blinking, that simply means if you open that raw file, all that would be there is like white. Same goes in the black direction also, where it's like black. You never want to be there. No, it cannot be fixed in post-processing. So once you messed it up, you cannot fix it. You cannot send AI to magically fix it. AI may be able to paint on top of it. It kind of like, okay, water, that's how it's supposed to look. Let's just paint on it. But that would be faking it. So you have to understand, it cannot be fixed in post. Once it's clipped, the end. That's why we want dynamic range as high as possible. Meaning the blackest black it can capture, the whitest white it can capture, it should be huge. And this is another reason why Blackmagic is not as popular as you may think. On paper, Blackmagic cameras are like amazing, latest and greatest thing, but you'll rarely see them used. That's the reason, because if you compare A7S2, this is old chart, you can see it can capture a very large amount of portion, basically bright to dark. It can capture a lot of it. Then you compare it to RE Alexa, a cinema grade camera. It's like, now you understand why the heck it's a cinema grade. It goes to this extent, like a lot of data it can capture. You go to Blackmagic, it's like, it's less than Sony. And that's the whole point. Like you can have a camera that's like 12K, but if this sucks, flat out is useless. And if you are familiar with handycams, back in the days when handycams used to use digital tapes, the tapes did not have compression artifacts, but footage still looked garbage. Why? Clipping. It was always like this. That's how it's shot in some old equipment. Even modern mobile phone will have some detail here. The moment you capture it with a like old handycam, you're like, this data would be good, but this will be blown out. And that's how you know that old timey look, the handycam look. That's what people are talking about, like low dynamic range. And that's why like modern cameras are no longer focusing on making megapixel resolution the core priority. They are focusing on dynamic range, because that's the easiest way. If you create a file that is truly very high dynamic range, your eyes can move around, adjust, and you will feel like I was there. because like your eye cannot adjust for you, but here is like eye is like, I got this, I got this, I got this. That's what we want. And this is the biggest difference between cheap camera and expensive camera. And IMAX people were really ahead of this, flat out. Like when IMAX was started, like long ago, people figured it out. Like flat out, having that big of a film stock had enough surface area, enough reaction area, where it's like, dude, almost everything was captured. And negatives are really good in blown out area, not in dark. Black will become just noise, but a blown out area would be still recoverable to surprisingly large extent. Meaning overexposure is like manageable. So that was a very moving forward ahead. IMAX was fundamentally ahead. However, today's time, like today's camera technology, digital has caught up. And if you are in a scenario where it's like, I want to make an IMAX camera that bitch slaps IMAX in every way, you can even exceed current digital camera by having 3 sensors, RGB sensor. People use that for 8K video transmission of Olympics and all that jazz, because at 8K transmitting at continuously, debayering algorithm will take too much power. So they just have 3 sensors. If you do that for cinema camera, it would be god tier amazing. We used to do that. Nowadays, a single sensor is good enough. And unless you are dealing with color critical work, meaning industrial power plants where they are dealing with fabric and they need the color to be precise, they have that 3CCD system or 3CMOS sensor. The color of those puppies are on a different level, like true color. That will bitch slap negative all day long. That's like, bro, no, don't come close to me. So what about the ISO or sensitivity? Flat out. If you take IMAX system, it fundamentally handles overexposure much better. Meaning, if you are in a plane and it's going around the white area, white clouds and all that, IMAX is like, I got you, guy, I got you. What about digital? Well, digital will overblow. However, that's why you keep hearing people talking about, like, we have to use ND. That's the whole point. If you can put sunglasses on your digital system, it will now bitch slap basically negative system. Why? Because you tone down everything and digital can see in the dark. Flat out, we have negative systems that are very good at low light, and then we have digital system that is literally night vision. And that night vision is like your Sony A7S III kind of camera. This is a movie, and this time this was a kind of a bold choice to go with a digital camera, because that back then they were not that good, but they did all the testing, and reality was, unless they had a lot of light, negatives were flat out useless. So the moment they had to do intimate scene inside a car where they're like to completely dark, completely serious, native was not capturing anything, so they had to use digital camera. It was a big move. Like, it's a subtle thing, because again, the film has like both of them, digital and negative, but it was very early on, and the moment people saw like it can be captured in such a low light, were like, whoa. So that's why, flat out, you can talk all day long about everything. The moment it comes to low light, negative does not stand a chance. Flat out, like, there is no point. Like, no, just no. And why the heck then people have so much love for film if scientifically digital is so better? Because here's the deal, film has this grain. Every Tom, Dick and Harry was like, it has grain. So what does that mean? Those particles, the particles that are actually changing its properties, that you chemically expose, those particles are actual powder. So inherently that powder noise is there. And it is organic. You cannot tamper with it, you cannot create an algorithm for it. Flat out is inherently organic. And it's organically different in every frame, meaning one frame, it has powder structure is different. Second frame, completely different. So every time IMAX is like you're rotating a spool, it's like completely different noise pattern. It creates an organic feeling that we like. Now, why do we like it? Well, the reality is our eyes are not that good. We have reached a point where digital camera can create such a sharp image that if you blow it up, like let's say A7 R series cameras with really good G Master lenses, if you really blow it up, like you can see cracks in human skin. You don't want to see that. You're like, it's like, too much sharpness. And many times, like, glimmer lenses are there. Like a lens whose sole job is to make things blurry, because we made it too sharp. And that was made back in the days of negative, because lenses were becoming good. People were like, dude, it just does not look good. It just does not look good. It's like, there is a sharpness at some point. It's like, dude, no. Like for doctors, that's awesome. That's how they want to see your x-rays and all that jazz. The moment you see a human photo like that, it's like, it just feels wrong. It's like, dude, it's too sharp. So that's why people love like salivate over the organic grain, the feeling. And digital ISO inherently does not have that feeling, because it's the same sensor, it's fixed. All it will do is like, noise will go up with temperature. And many of the cinema system has a cooling system, so that also does not change. So inherently it does not have that same organic feeling. But you have to come down to reality, and you have to understand one core aspect. At the end of the day, it's all about the feeling. Meaning, you are the producer, you are the director, you are whatever. You are deciding what your movie should look like. Like for example, this movie, they decided it's like, for days sight of scene or scenes where we have a lot of ambient light, we'll use negative. It's like we need intimacy in digital may work for you. Maybe that noise back in that day was like, whoa, it gives us some uneasy feeling. Maybe you want that, maybe you desire it. At the end of the day, movie is not scientific data. If it was scientific data, we will never talk about negative again. It is a feeling thing. Like, how do you feel about it? That's the end of the game. And IMAX will not make your movie magically into magic, flat out. You can make Tenant all day long, but it will still be a bad movie. Yes, it is a bad movie. I flat out said it. It's just a bad movie. A misunderstood masterpiece. No, it's a garbage movie. It's like a idiotically idiotic movie. And like even one of my not fan, as in like one of my friend who was a big fan of Christopher Nolan, he was like, he watched Tenant, he was like, yeah, I understand. This is garbage. It's like at some point, it's like, bro, this is just bad. Just because it's shot on IMAX does not make it better. And I genuinely hate that frame clipping. It's like, dude, scale one of them up or scale one of them down. Just don't change it. But anyway, and most of the time when you are talking about IMAX temper, all that, they are rarely using that true real film. There's one or two movie, but that's it. Majority of the movies that have IMAX formatted for IMAX, they don't use that. They use these things, meaning RE Alexa LF, that is 4.5K, RE Alexa Mini LF, that is 4.5K, Panavision Manilium DXL2 8K, Red Ranger Maestro 8K, Sony Cine Atlas Venus 6K, RE Alexa 65 IMAX, which literally has the film like sensor size of 65mm. At that point in time, they're like, dude, there is no actual reason to jump into like negative 60. Like that's truly that good, and that's 6.5K. That's why I said the K does not matter. Like this is certified by IMAX itself. So IMAX stamp that is on it is validated. It's not like, oh, it's IMAX quality. No. It's validated by IMAX. So that's why you have to understand. At the end of the day, if you want that scientifically the best good looking technology, you will use digital. If you're like, I love that feeling, I love that noise, I love that grain. Many people are saying that nowadays they can create grain generator basically that can create a noise feeling that almost can fool anyone. And I tend to believe them, because be mindful. While you said Tenant has been shot on this and that, but it also has CG. So how the CG element blends in? We know how to create noise. It's just that people, that feeling, watching it 200-inch screen, that feeling. It's all about that feeling. So that's the ISO side of it. So this was my presentation on basically IMAX versus digital. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.